Alrighty, friends, we have questions 9 and 10 from page 117. Number 9. This is a square with 24 square units is placed beside a square with area 50 square units. In simplest form, write a radical expression for the perimeter of the shape formed. Okay, so this is number 9. You've got one box like this and one that's a little bigger. Okay, this one's 24 square units. And this one's 50 square units. Now it doesn't just say these are, rectangles or a shape or whatever. It says they're squares. So that means that each side is equal. If this big box, if the area was 100, then each side would be 10, right? You just take the root of it. So now, because it wants the perimeter, write a radical expression for the perimeter. Yeah, it wants perimeter. So again, just pretending this was 100. You take the root of 100, and let's just also pretend it's by itself. Root of 100 is 10, so it'd be 10 plus 10 plus 10 plus 10, right? Obviously, this is much more complicated, but that's the gist of it. If it was 100, we take the root of it. We're taking the root of these bad boys. The root of 24, and it also says it wants it simplified. I just gestured to the book as if you could see the book. So we have the root of 24. Let's just start there. Simplified, okay? 24 is 2 times 12, 2 times 6, 2 times 3. So the root of 24 equals 2 root 6. Okay, that's the root of 24 simplified is 2 root 6. 2 squared is 4, taking that in, 4 times 6, 24. For 50, same idea. 2 times 25, 5 times 5, so 50 is 5 root 2. Okay, there's our pair. If this was cube root, we would take the 3 2's. 5 root 2. 2 root 6 and 5 root 2. That is the side length. Sorry, this makes it look like all the sides are the same. They're not. 5 root 2, that's this side, that's this side, that's this side. 2 root 6, that's this side, that's this side, that's this side. And then we just have to figure out that little bit right there. Well, to my way of thinking, that little bit is 5 root 2 minus 2 root 6. So, to kind of summarize here, 3 of these, right? 1, 2, 3. 3 times 2 root 6 plus 3 of these. 3 times 5 root 2 plus, and I'm going to run out of space here, plus, there will I? 5 root 2 minus 2 root 6. Okay, remember this part here is this space right here. This space is 5 root 2 minus 2 root 6. That's what that little space is. And then we got 3 of these sides, 3 of those sides. So we just have to simplify this. So this equals 3 times 2 is 6, so that's 6 root 6. 3 times 5 is 15 root 2 plus 5 root 2 minus 2 root 6. So we collect like terms. It's a root 6 and a root 6. So 6 minus 2 is 4. 4 root 6. 15 root 2 and 5 root 2, so it's 15 plus 5, so that's 20, plus 20 root 2. That is the simplified simplified perimeter of 9. That's what I want, right? Simplified radical expression perimeter. Yeah. Just double check my answer. 4 root 6. This is number 9. 4 root 6, 20 root 2. Yeah. It has it in different order. It's got the 20 first. It doesn't matter at all. 3 plus 1 is the same as 1 plus 3. Okay, that's number 9. It's a great question. It's a fun question. That's an old letter on the back of that. Number 10. Oh my. My camera is on a stack of CDs. It slides effortlessly across the desk. Number 10 from page 117. Let's look at this. So this is what this thing looks like. It's probably a touch blurry for you. Better? All right, Can I point with this? So it says 2 squares are enclosed in a large square. So this and this, I suppose. This area of the smallest square is a squared units. So the root of a would be the side length, right? The area of the middle square, this is middle, I assume, because this is the largest. Of the middle square is 4a, so this is the area. So the root of 4a, or 2 root a, is the side, okay? Determine the area and perimeter of the shaded region in terms of a. So use that a value. All right. It wants the area and perimeter of the shaded region. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so the area of the shaded region is exactly the same as 4a. Okay, so the area of the shaded region is 4a. No need to write anything down to show that. Just counting squares. We want to look at it somewhat visually. Look at this kind of rectangle. That's half of the square. This one is also half. Just turn it to put it in the side. Perimeter, though, is trickier. I'd be tempted just to go with the smallest. I'm sure you could do it both ways, and maybe I should. But the side length of this thing is the root of a. Okay, this is the root of a. That's the side length of this square with an area of a. Side length is the root of a. So if we want perimeter, we just need to figure out how many of those there are. So for every 2 blocks, it's the root of a. So I'm starting right at this corner, okay, so I don't lose my spot. So we have 1. One group is 2, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the perimeter is 10 root a. The area is 4a. Does that make sense? Check my work. Area is 4a, perimeter is 10 root a. 10 root a, yep. I hope that makes sense. If it doesn't, I'm more than happy to give you more info. Let's see the CDs. What CDs do I have? Let's see the CDs if this camera bends. Laundry. See that there? That's laundry. And note it's on the treadmill. What does that tell you? Stay in school, kids. Look at that. Great Big C. I didn't care for that album. Oh, I'm trying to move it closer into the camera. I didn't care for that album. Okay, bye.